Question number 5 on your exam reads, describe the Bohr effect. The Bohr effect is largely focused on the amino acid histidine. Please describe how an oxygen binding curve would change and how hemoglobin's function would change if the histidine were mutated to a lysine. Histidine to a lysine. And please describe the same things, but if the histidine were mutated to an aspartic acid. Okay, so, well, the Bohr effect, in a nutshell, is hemoglobin binding O2 and movement from the T to the R state. Now, the T state is favored when histidine is protonated. So when histidine is protonated, that's going to be at a lower pH. What that is going to show is an oxygen binding curve. That's not drawn particularly well, but it's going to shift to the right. And whenever it shifts to the right, then your P50 goes up. Okay, so a description of the Bohr effect would simply be protonation of this residue results in favoring of the T state and therefore an increase in the P50. Okay, now next up is, so that would be kind of part 1. Part 2, part 3. Part 2 is if this histidine is mutated to a lysine, what happens? Okay, so independent of the different shape and the different size of those amino acids, I think it's worth recognizing that these two amino acids are kind of, well, they have different shapes, certainly, but they also have different pKa values. So histidine has a pKa, histidine side chain, I'm sorry, has a pKa of 6.04. Lysine has a pKa of 10.67. Okay, so what we would observe is, well, nothing really changes in terms of the favoring of the T state at a lower pH, but at a physiological pH, of 7.4, we're super far from our, we're super far from the pKa of 10.67. And so this is totally protonated, whereas this histidine is almost within the buffering range. And so what you would see is basically, you would see that shift, but you would have to go to a significantly higher pH rather than a physiological pH. You'd have to go to an even higher pH in order to get this deprotonated. So that lysine is going to remain protonated at a physiological pH, which is going to result in locking in the T state. Okay. Now, part 3 of this question is, please describe the same things, but if the histidine were mutated to an aspartic acid. Okay. Now, aspartic acid, H going to D, 6.04 to, I got an alt tab here. I gave you guys this structure though. Aspartic acid is 3.71. Okay, so now what we'd have is, if the deprotonation of this amino acid is really kind of the important part of this, well, at a pH of 7, or a pH of 7.4, that residue is going to be 100% deprotonated. And so we're going to be confronted with a bit of a problem there, because that amino acid is going to be deprotonated, therefore we have a negative charge there. Therefore, it's not going to even stabilize the T state. Instead, we're going to be favoring the R state. Okay, so basically what this boils down to is part 2 is favors that was a V that just disappeared, favors T state, and part 3 favors the R state. Okay, well I hope this is helpful. This is problem number 5 on your exam. Broken down into 3 different parts, so about 1/3 of a point per.